9.1, and we're going to be looking at multiplying and dividing rational expressions. So first thing we're going to go into is the vocabulary. So in the vocabulary, we have a couple of terms that you may or may not have seen before. The first one is rational expressions. And a rational expression is just a ratio of two polynomials. For example, you can see that x squared minus 2 divided by x plus 3, those are two separate polynomials, multiple terms in this particular case, and actually that's not always necessary for it to be a rational expression, but in this case it is. So here's one polynomial, here's another polynomial, we're dividing the two, so that means ratio, and that's when we're talking about rational. So rational, of course, is also division. So that's what we're looking at. Another term that you need to know is the greatest common factor. So if we're looking at the denominator, we're always trying to figure out what is the greatest common factor. That should not be an 85. I guess it's a little bit hard to see, but in that particular case, that should be 8 times 5. And so with of course 35, we have 5 times 7. Actually, I'm going to just do it in parentheses because I don't want to make it look like a minus sign. So we have 5 times 7 and 8 times 5. And then what we always look at is my greatest common factor, which means what's my common factor for the two terms when we're starting to look for things. So that's going to be important, is that you always want to break it down as far as you possibly can to be able to do that. So in this particular case, you look at, again, the denominator is the one that's important, even though we will also be factoring the numerator. But remember, this is a difference of squares, so that is x plus 2 times x minus 2. So that would be factor out to that one. And this one up here would factor out to x minus 3 and x plus 2. Because remember, the two numbers have to add up to multiply to negative 6, and they have to add up to negative 1. So these two add up to negative 1 and multiply to negative 6. And then we can start doing some canceling. As you can see here, I can cancel some things here, just like over here. You can see that I can cancel some things over here. Okay, so we're going to go ahead and work on our first problem. That is to simplify an expression. So we have x squared minus 16x plus 64 times x plus 2 over x squared minus 64 times x squared minus 6x minus 16. Now, anytime we're trying to simplify, it's important to make sure that that you factor everything down as much as possible and then cancel anything that could potentially be canceled. And that's for part A. Then part B, we want to state what when the original rational expression is undefined, and I'll explain that as we get to it. So first thing is we want to factor. So we're going to factor this one first. We want to find out all the multiples of 64 that are going to add up to negative 16. Now, of course, remember, this is a positive. Positive tells me that the signs have to be the same. This negative tells me they both have to be negative. So if we look at different numbers there, we can see that negative 8 plus negative 8 is negative 16. So that would be my factoring there. And because we have a 1 in front, we can do it just using the table. We don't have to do the box method. So we have x minus 8, x minus 8, x plus 2. Okay, we could have written it as x minus 8 quantity squared. Easier sometimes to write it this way. Now, x squared minus 64 is actually a difference of squares, so it is x minus 8 times x plus 8 because the middle term disappears. And then on this last one, we have negative 16, and we can figure out what values of negative 16. So that means this tells me one has to be positive, one has to be negative. This tells me the larger one has to be negative. And so they have to add up to 6. So if we have 2 and 8, 2 times 8 is 16, and 2 plus 8 or 2 minus 8 is negative 6 in that particular case. So therefore, it's going to be x plus 2 and x minus 8. So what's going to happen in that particular case is we can see that this x minus 8 and this x minus 8 cancel. This x plus 2 and this x plus 2 cancel. Notice that and then this x minus 8 cancels with this x minus 8. So you notice we have, in a sense, nothing left on top, but we really do. We have 1 over x plus 8. So that would be my final answer when I simplify it. Now for part B, when is the original undefined? So what we want to do is we want to look at when do any of these terms go to 0? So at what numbers? So like if I plug in x equals 8, that's 0. We can't have 0 in the denominator. So it is undefined when x is equal to 8. And in this case, when x is equal to -8, and it's undefined when x is equal to -2. Now notice this one is also when x is 8, but it's already in there. So therefore, we just leave that alone. So that takes care of the first simplifying problem, and we'll move on to the next problems in the next video.